Welcome to the Algebra 1 Chapter 10 Review Answer Key Video Explanation. So right away we'll look at examples 1 and 2 with adding or subtracting polynomials. Now what you want to keep in mind with problems like these are you can combine like terms, whether it's adding or subtracting, if they have the same variable and the same power. So for example, in number 1, x squared here can be added to the 5x squared to give me 6x squared. The positive 4x has nothing else with just x to the first power, so we bring that down. And a negative 1 plus 2 is a positive 1. So after combining like terms, our answer would be 6x squared plus 4x plus 1. In number 2, we're subtracting the different polynomials, but we're still using the same rule for combining like terms. So the 7n to the third minus 4n to the third gives me 3n to the third. A positive 2n squared minus a negative 3n squared is the same as addition, so that'd be 5n squared. The negative n has nothing to combine with, so we bring that down as minus n. And a negative 4 minus 8 more would give us a negative 12 at the end. So our final answer would be 3n to the third plus 5n squared minus n minus 12. Now moving down to 3 and 4, and this whole section is asking us to find the product. So if it's a binomial times a binomial, we can simply FOIL it. So first outer, inner, last. So right away, I just caught that there's a mistake on this one because in front it should be a 2x squared because x times 2x is 2x squared. Then in the middle, 2x times 3 is plus 6x. X times a negative 7 would be a minus 7x, and the last 3 times negative 7 is minus 21. So after we combine like terms, this should also be a 2x squared here. We'd have 2x squared minus x minus 21. Looking at number 4, 9x minus 4 times 9x plus 4. So in this case, using the FOIL approach, 9x times 9x is 81x squared. A negative 4 times 9x on the inside and a 9x times positive 4 on the outside would cancel. So then we just have to do our last term, negative 4 times positive 4 minus 16. So it would be 81x squared minus 16. Now with 5. We have a binomial multiplied by a trinomial, so we want to take each term in the binomial and distribute it to the trinomial. So we'll start with taking the w and multiplying it by each part of our trinomial. So w times 4w squared is 4w to the third. W times w is w squared. W times negative 7 is minus 7w. Then we distribute the negative 6. Negative 6 times 4w squared is minus 24w squared. Negative 6 times w is minus 6w. Negative 6 times negative 7 is plus 42. Then we look across this row and combine like terms, and we end up with 4w to the third minus 23w squared minus 13w plus 42. Oh, screen switching on me. Back to where we should be. Apologies. There we go. 6. So dealing with number 6 here, we have 7x minus 2 to the second power. So it's in parentheses. So that's the same as 7x minus 2 multiplied by 7x minus 2. So in that case, use the FOIL approach, first outer, inner, last. First, we'd have 7x times 7x, 49x squared. Inner, a negative 2 times 7x is minus 14x. And then the outer is another minus 14x, so that's minus 28x. And then at the end, negative 2 times negative 2 is a plus 4. This is also a special case, so you could use your special products as well. Now we go down to the next section, which has to deal with factoring each expression completely. So here we were finding the product. Now we're taking the product and factoring it back into different parts. So right away with 7, we have x squared minus 9x plus 14. So what we want to think about are two numbers that multiplied equal a positive 14, but added equal a negative 9. So a negative 7 times a negative 2 is positive 14. Negative 7 plus negative 2 is negative 9. So I'd have x minus 7 in parentheses times x minus 2, and that is now factored. If you want to check if you factored correctly, we could FOIL your answer, and it should come back to be the original. With 8, we have 3x squared plus 42x minus 96. So right away, I notice each one of these can be divided by 3, so I factored out the 3. Then I have x squared plus 14x minus 32, so I want to factor that trinomial, something that multiplies to be a negative 32, but added would be a positive 14. So that gives me x plus 16 multiplied by x minus 2. And then we brought down the 3 that we originally factored out. With 9, we have 2x squared plus 5x minus 12. So I know my binomials, one will start with 2x, the other with x. Then I need something to multiply to be negative 12 and add to be 5x. Well, a 4 and a 3 multiply to be 12. 2x times 4 is positive 8x. Negative 3 times x is minus 3x. So 8x minus 3x would give me the 5x I need in the middle. So we have 2x minus 3 times x plus 4. In 10, right away I notice I can factor an x out of each one of these terms. So I factored out my x, and I'm left with 4x squared plus 21x plus 20. Then, to factor that trinomial in the middle, it would break down to 4x plus 5 times x plus 4. Because 4x times 4 here would be 16x, 5x in the middle. So 16x plus 5x gave me the 21x I need in the middle. And then 5 times 4 at the end gave me my 20. Moving down to the last 4 on the first page. In 11, 18x squared minus 50. Both can be divided by 2, so we factor out that GCF of 2. And I have 9x squared minus 25. 9 is a perfect square. 25 is a perfect square. So I know this problem is a difference of two squares. So it'd be 3x plus 5 and 3x minus 5. And then we have to bring down that 2 that we originally factored out. In 12, I have a perfect square trinomial. Square root of 16 is 4. Square root of 9 is 3. We need a negative in the middle, so it has to be minus. So this should be an n, not an x, but it would be 4n minus 3 squared, or 4x minus 3 squared. Whatever variable, same thing. So can make that an n, exact same answer. Now with 13 and 14, anytime we have 4 terms that can't be combined, we want to use grouping from lesson 10.8. So in 13, I group my first 2 terms and my last 2. In the first 2, I can factor out a y squared, leaving me with 3y plus 1. In the second 2 terms, I can factor out a 5, leaving me with 3y plus 1. So then, using grouping, we combine what's outside, the y squared plus 5, and that's our first binomial, y squared plus 5, times our second binomial, 3y plus 1. And that would be our final answer. 14. We group the 2x plus 3 and the 3x squared, and we can factor out an x squared, leaving me with 2x plus 3. Then in the next part, we have a negative 8x minus 12. So I can factor out a negative 4, leaving me with 2x plus 3. So then on the exterior, x squared minus 4 becomes x squared minus 4 for my first binomial, multiplied by 2x plus 3. Now if you left your answer at this step, for your level, I'd be okay with it. But to technically factor completely, we would want to notice the x squared minus 4 can further be factored to x plus 2, x minus 2, because it's the difference of two squares. But I would take this answer or this answer for your level. Now we're into the zero property. And again, if we're solving using the zero property, it means take each part of our answer on this side and set it equal to 0. So x minus 3 equals 0, x minus 2 equals 0. When we solve for x, we'd add 3, so x equals 3. Add 2 on this one, where x equals 2. So our answer would be x equals 3 and x equals 2. 16. We take each part, set it equal to 0. So 8x equals 0. Divide by 8, and x is still 0. 4x minus 5 equals 0. So we'd add 5 and divide by 4. So x is 5/4. And 2x plus 1 equals 0. So we'd subtract 1 and divide by 2. So x is a negative 1/2. Now 17 and 18, 19, 20, they want us to solve by factoring. Meaning the first thing we have to do is get our whole piece equal to 0. So in 17, we need to add 49 to get rid of this negative 49. So we'd have x squared plus 14x plus 49 equals 0. Right here, we have a perfect square trinomial. So x squared plus 14x plus 49 factors to x plus 7 times x plus 7, or in other words, x plus 7 in parentheses squared. So we would just have to solve x plus 7 equals 0. Subtract the 7, so x equals negative 7. 18. X to the third minus 5x squared minus 14x equals 0. I notice I can factor an x out of my original trinomial, so pulled out the x, and I want to then factor x squared minus 5x minus 14. That factors to x minus 7, x plus 2. So then we set each part equal to 0, x equals 0, x minus 7 equals 0, x plus 2 equals 0, and we get our final answers of x equals 0, x equals 7, and x equals negative 2. Now down to 19 and 20. Again, we want to make sure it's equal to 0 to start. So in 19, I need to add 21 to each side, and I have 2b squared minus 17b plus 21 equals 0. Factor the 2b squared minus 17b plus 21, and that becomes 2b minus 3 and b minus 7. Set each one of those binomials equal to 0. 2b minus 3 equals 0, so we add 3 and divide by 2, meaning b is 3/2. B minus 7 equals 0, so add 7, b equals 7. Now with 20, x to the third plus 2x squared minus 32 equals 16x. I want to subtract 16x from each side so it equals 0. So I'm going to write that in standard form as x to the third plus 2x squared minus 16x minus 32 equals 0. Then I want to factor each part after I group them. So our first one, I could factor out an x squared, and I'd have x squared, and then in parentheses, x plus 2. In the second one, I can factor out the negative 16, and in parentheses, that leaves me x plus 2. So then we'd have x squared minus 16 in the first parenthesis, x plus 2 in the next. In order to fully solve this, though, we need to realize x squared minus 16 is the difference of two squares, which is x plus 4, x minus 4. So then we'd have x plus 4 equals 0, x minus 4 equals 0, and x plus 2 equals 0, giving us our final answers of negative 4, 4, and negative 2. Then we get down to our last two examples, 21 and 22. So in 21, we have 4x, or 45x squared, minus 240x plus 320 equals 0. Right away, I notice all of these can be divided by 5, so I factor out a 5. That leaves me with 9x squared minus 48x plus 64 equals 0. This part here, a perfect square trinomial, would factor down to 3x minus 8 times 3x minus 8. So 3x minus 8 in parentheses squared times 5 equals 0. Set each part equal to 0. Well, 5 never equals 0, so we don't need to worry about that. 3x minus 8 equals 0. Add 8, divide by 3, and x equals 8/3. And lastly, with 22. Right now it's equal to 25n, so I need to subtract 25n from each side so it equals 0. So I have 14n to the third minus 64n squared minus 120n equals 0. I can factor out a common factor of 2n. That leaves me with 7n squared minus 32n minus 60 equals 0. Then I can factor this trinomial. We need something to multiply to be negative 60, add to be a negative 32. And our setup would be 7n plus 10 multiplied by n minus 6. Because if we FOIL that, 7n times a negative 6 is a negative 42n. N times a positive 10n is a plus 10n, so negative 42 plus 10 gives me the negative 32n I need in the middle. So then we take each part, set it equal to 0, so 2n equals 0, 7n plus 10 equals 0, n minus 6 equals 0. Solve for n, and we have n equals 0, n equals a negative 10/7, and n equals 6.